Alright, we're going to now work on Pythagorean's theorem. You probably already learned a little bit about Pythagorean's theorem last year, but we're going to make it a little bit more difficult this year. Of course, that's what we do in algebra, right? So the whole purpose of Pythagorean's theorem is to find a missing side on a right triangle. So last year I think you guys always found the hypotenuse. This time we're going to actually find any side. And the key is it has to be a right triangle. I'm not going to give anything to you this year that's tricky where it's not, but in the future they may. The equation for Pythagorean's theorem is a squared plus b squared equals c squared. And the parts of a right triangle that we need to know is the side across from the right angle is known as the hypotenuse. And this is super important because it is always c in the equation. That's the only one that matters. These two sides are known as the legs, and it can be A or B. It doesn't matter which one is which. But the hypotenuse is always C, and the hypotenuse is always the longest side as well. So if I just gave you three sides, we can quickly identify which side is the hypotenuse because it's the longest. All right, so we're going to just practice using this. So I always start by saying, okay, which one must be C? This must be C, so we're going to plug it in. We've got 9 squared plus x squared, because that's my A and B, equals 27 squared. Now some people think we could just cross off the squareds, but because of order of operation, we can't do that because there's an addition sign in between. So this is going to become 81 plus x squared equals, and 27 squared is 729. So all I did was square each of those. Now it's going to turn into a tracks problem. So I'm going to take away 81 from both sides. And I get that x squared is 648. Now I need to square root both sides. I'm just going to kind of come up here because this is going to take a minute. So I have the square root of 648 is my answer, is what x is, but we have to write it as a simplified radical, meaning I can't keep it in this form. So either we can look, is there a perfect square that we know that goes into there, or how else would we do it? So I'm going to kind of start and say, well, let's see. I think it can be divided by 4. So 648 divided by, oops, sorry guys. 648 divided by 4 is 162. That can be divided by 2. 162 divided by 2 is 81. Okay, I see. So actually this kind of helped out quite a bit because this is kind of what I'm seeing now. So if you remember back to our last unit, that's the same as the square root of 4 times the square root of 2 times the square root of 81. Those numbers are super helpful because I can take the square root of 2 of these. I know the square root of 4 is 2, the square root of 81 is 9, and I'm left with the square root of 2 that's left. So it's 18 square root of 2 is my answer for that. Okay, our next one here. So this one, I'm going to start with my C. That's my C. Those are my A and B. It doesn't matter which one is which, so I'm going to say 45 squared plus 24 squared equals C squared. 45 squared is 2025. 24 squared is 576 equals C squared equals C squared. So this one is kind of a yucky one. I will say one little thing, when I get numbers that are this big, I think, oh shoot, let me see if I can figure out, is there a nice square root just from the beginning? So I'm going to sit and try that. So 2601, which you probably can't see my calculator, sorry guys. And I'm just going to square root that. And it's a nice square root, it's 51. So 51 is C squared. Otherwise, is C. Otherwise it would take a little longer. But yay for that. All right, last one down under. Start by identifying my C. This must be C, so I have x squared plus 36 squared equals 42 squared. I'm going to square both of those numbers, so 36 squared is 1,296, and 42 squared is 764. I have my tracks problem. Take away 1,296 from both sides. And I get x squared equals 468. Okay, so I'm going to try to then simplify that, and I get x squared, square root both sides, and then I have to simplify. So if I look at 468, I say, okay, what can I... Okay, so here we're at with the square root of 468, so we're going to try to simplify that. Square root of 468, well, I can see it can be divided by 2. So square root of 2 times 234. I can then split that as square root of 2 times square root of 117. Would not expect you necessarily to get this next one, but that is the same then as the square root of 9 times the square root of 13. So this looks a little funky, but if I kind of now piece these together and say that's the square root of 4 times the square root of 9 times the square root of 13, these are ones I can take. Square root of 4 is 2, square root of 9 is 3, square root of 13, no clue. So the answer to this would be 6 square root of 13. All right, good luck, guys.